Space may look peaceful. When we look up at the night sky, we see tiny points of light frozen in place, almost unchanged from one night to the next. But that is an illusion. Across the universe, stars are exploding with the force of entire galaxies. Black holes are tearing stars apart atom by atom. Neutron stars are colliding so violently that they create gold, platinum, and some of the most powerful explosions ever observed. These aren't just powerful events, they're among the most extreme acts of destruction nature is capable of producing. Today, we're counting down 10 of the most violent phenomena known to modern science, and by the end, you'll see why even the most terrifying forces on Earth barely register on the cosmic scale. We'll start relatively close to home. The sun may seem calm compared to the monsters we'll discuss later, but it is capable of unleashing staggering amounts of energy. Solar flares occur when twisted magnetic fields above the sun's surface suddenly snap and reconnect. In just minutes, they can release energy equivalent to billions of nuclear bombs. Often accompanying them are coronal mass ejections, enormous clouds of electrically charged plasma blasted into space at millions of kilometers per hour. Fortunately, Earth's magnetic field protects us from most of the damage, but powerful solar storms can disrupt satellites, communication systems, GPS networks, and electrical grids. Compared to what comes later, these events are relatively mild. But they remind us that even our own star is capable of cosmic violence. When a massive star reaches the end of its life, gravity finally wins. For millions of years, nuclear fusion pushes outward while gravity pulls inward. Eventually, the fuel runs out. The star's core collapses in a fraction of a second. Temperatures soar into the billions of degrees. Matter is crushed to incredible densities. Then the entire star explodes. A supernova can briefly outshine an entire galaxy. During the explosion, elements such as oxygen, silicon, calcium, and iron are blasted into space. The atoms in your body were forged in stars like these. In other words, every person on Earth is made from the debris of ancient stellar explosions. Violent as they are, supernovae are also creators. Without them, planets and life itself would never have existed. Imagine taking the mass of the sun and compressing it into a sphere only about 20 kilometers across. That is a neutron star. Now give that neutron star the most powerful magnetic field known in the universe. You get a magnetar. A magnetar's magnetic field can be more than 1,000 times stronger than that of a typical neutron star, and trillions of times stronger than Earth's magnetic field. The magnetic stress can literally crack the star's crust. When that happens, the magnetar releases colossal bursts of X-rays and gamma rays. In 2023, astronomers observed a giant flare from a magnetar in the galaxy M82 that released an extraordinary amount of energy in just a fraction of a second. If a powerful magnetar flare occurred close enough to Earth, it could significantly affect our atmosphere and technology. Fortunately, no known magnetars pose that kind of threat. For decades, gamma ray bursts puzzled astronomers. Today, we know they are among the most energetic explosions ever observed. Some occur when massive stars collapse into black holes. Others happen when neutron stars collide. For a few seconds, an immense beam of gamma radiation erupts into space at nearly the speed of light. If one of these narrow jets happens to point directly towards Earth, the burst appears unbelievably bright. In only seconds, a gamma ray burst can release as much energy as our sun will emit during its entire lifetime. These explosions are so luminous that some have been detected from billions of light years away. They're essentially cosmic searchlights visible across much of the observable universe. Two neutron stars orbiting each other create one of the most violent dances in existence. As they circle, they emit gravitational waves and gradually spiral closer together. Eventually, they collide. The impact occurs at a significant fraction of the speed of light. Matter is compressed beyond anything achievable on Earth. A brilliant explosion known as a kilonova follows. These collisions are thought to create large quantities of heavy elements such as gold, platinum, and other rare metals. The famous 2017 event known as GW170817 allowed scientists to observe gravitational waves and light from the same cosmic catastrophe for the first time. It marked the beginning of a new era in astronomy. Imagine drifting too close to a supermassive black hole. The side of your body nearest the black hole would feel a stronger gravitational pull than the far side. The difference becomes so extreme that you would be stretched apart. This process is called tidal disruption. When it happens to a star, the result is known as a tidal disruption event. The star is literally shredded by gravity. Some of its material is flung outward. The rest spirals into the black hole, heating to enormous temperatures and producing a brilliant flare visible across vast cosmic distances. For a brief period, a single doomed star can outshine its host galaxy. When two black holes collide, something remarkable happens. There is no giant flash, no explosion visible to ordinary telescopes. Instead, the violence is carried away by gravitational waves. As the black holes spiral together, they warp space and time itself. At the moment of merger, enormous amounts of mass can be converted directly into energy. The first detection of a black hole merger in 2015 confirmed a major prediction of Einstein's theory of general relativity. Since then, hundreds of mergers have been detected by observatories such as LIGO, Virgo, and Kagra. These events rank among the most energetic phenomena ever measured. The difference is that much of their energy leaves as ripples in space-time rather than visible light. At the center of many galaxies lie supermassive black holes. Most are relatively quiet, some are not. When huge amounts of gas fall toward a supermassive black hole, an intensely hot accretion disk forms around it. The resulting object is called a quasar. Quasars can shine brighter than entire galaxies despite originating from a region smaller than our solar system. The energy does not come from fusion, it comes from gravity. Matter falling into the black hole releases enormous amounts of energy before crossing the event horizon. Some quasars were already blazing when the universe was less than 1 billion years old. Even today, they remain among the brightest objects ever discovered. Some active black holes do more than consume matter, they launch it. Magnetic fields near the black hole can accelerate particles into enormous jets traveling close to the speed of light. These jets can extend far beyond their host galaxies. In 2024, astronomers reported the largest known black hole jet system ever observed. Named Porphyrion, it stretches roughly 23 million light-years across. To put that into perspective, that's around 140 times the diameter of the Milky Way. These structures can influence the evolution of entire galaxies and galaxy clusters. They are among the largest and most powerful engines in the known universe. At number 1, we arrive at perhaps the most intimidating cosmic phenomenon currently known. A blazar is a special type of active supermassive black hole. Like other active galaxies, it launches powerful jets. The difference is orientation. One of the jets happens to be aimed almost directly at Earth. Because of relativistic events, the jet appears dramatically brighter than it otherwise would. The result is an object capable of producing staggering amounts of observable energy. Blazars are suspected of accelerating particles to energies far beyond anything achievable by human technology. Recent research investigating the highest energy neutrinos ever detected points towards blazars as potential sources. They are effectively cosmic particle accelerators operating on scales that defy imagination. And when one points in our direction, we witness some of the most extreme physics in the universe. The universe doesn't do things by halves. Stars explode, neutron stars collide, black holes devour suns, merge with each other and launch jets that span millions of light years. And despite everything we've covered today, these are only the phenomena we've discovered so far. Every year, new observatories reveal events more powerful, stranger, and more extreme than we thought possible. The truth is that the universe isn't a quiet collection of stars. It's an arena of constant creation and destruction, governed by forces so immense that our everyday experience barely prepares us to comprehend them. And somewhere, right now, one of these violent cosmic events is unfolding. The light just hasn't reached us yet. Thank you for watching this video. I hope you enjoyed exploring the most violent things in the universe. Let me know if you can think of any other violent cosmic activity that I may have missed down in the comments. Make sure you hit the subscribe button, and if you have anything you would like to explore with me in a future video, I will do my best to make that happen. Stay curious.